All right, so in this video, we're going to look at something called factor by grouping. All right, a lot of times the problem itself will actually tell you to use this method to factor a polynomial, but typically when you're going to look for it, it's when you have four terms. A lot of times when there's four terms, they kind of expect you to use factor by grouping. What we're going to do is we're going to look at the left half of the problem and the right half as like two separate problems, two separate factoring problems. And what we're going to do is we're going to factor out the greatest common factor for each. All right. So for the 4x cubed and the 16x squared, they have a 4x squared in common. So both terms have a 4, and they both have an x, or they have an x squared in common. So that's what I'm going to factor out of the left half. So the 4x cubed is going to become an x. So notice 4x squared times x is 4x cubed. And then the 16x squared, that's going to become a 4. Okay, 4x squared times 4 gives you 16x squared. The right half, we want to take out the biggest number we can, so that's going to be a 9. So it's going to be a plus, and then I'm going to factor out a 9. It's going to make that an x, and then the 36, when you divide it by 9, you'll get a 4. All right, so the idea here, what you want to happen is that you want there to be a shared factor between the left half and the right half. And that's what we have here. X minus 4 is showing up in both of them. So because both halves, both giant terms, I guess, because they both have an x minus 4, we're going to be able to factor an x minus 4 from each half. All right. So the left half is going to be a 4x squared now. So notice x minus 4 times 4x squared gives you this left half. And then the right half is just going to become this plus 9. All right, so x minus 4 times 9 gives us 9x minus 4. And that's it. That's the factored form for this expression. All right, we'll do another one here in this video. All right, this one is to the 6th power. All right, let's go with, all right, something that's going to make this a little bit different is that minus sign, you'll see. All right, the left half, they have a 3 and they have 4 x's in common. So it's going to be 3x to the 4th that I factor out. So my 6 is going to become a 2, and I need 2 more x's. So x to the 4th, x squared, that gives me x to the 6th. And then the 3x to the 4th, well, I factored out a 3x to the 4th, so it's just going to become a 1. 3x to the 4th times 1 gives me that one. All right, so on this left half, I know they have a 7 in common, but because the sign's a negative, I need to factor out a minus 7 here. All right. On that last example, it was a plus, or sorry, it was a plus up here, so I factored out a positive 9. So whatever the sign is there, you're going to keep that sign down here. But because it's a minus here, I'm factoring out a negative 7. So my signs are going to end up changing inside the parentheses here. That's going to give me a 2x and a plus 1. Oh, what am I doing here? I'm missing, yeah, I was missing something here. My bad. This is supposed to be a 14x squared, isn't it? Yeah, it's a 14x squared. I just wrote it down wrong. Sorry. So that's a 14x squared. So this is a 2x squared there. I knew something was up because these factors are supposed to be the same. Anyway, notice if you take the negative 7 and you distribute it back in, you end up getting a minus 14x squared and a minus 7. So, all right, now the last bit, they both have a 2x squared plus 1 in common. And then these numbers are going to be what goes in your second set of parentheses. 3x to the 4th minus 7. Okay, there's 2. and I'll do some different types of examples on the next one.